Hi, everyone, and welcome to Island Math. Today we're going to be discussing scientific notation. First of all, an overview. The standard form of scientific notation is a multiplied by 10 to the n, and I'll get to what that means in a minute. And this notation is used to express numbers that are either very large or very small. So what we're going to do here is take a look at what this means here. So a is just going to be some number, and at the end of it, you're going to put multiplied by 10 to the power of some number n. So, for instance, if we had the number 35 million, okay, this is a very long number to write out. So, for scientific notation, what you're going to do is put the decimal point right here. So between the 3 and the 5. So it's basically after the first significant number, which is 3 in this case. So we're going to have 3.5. And we're going to multiply that by 10, as the formula states, to the power of. And in order to find what power we're multiplying that by, we're just going to look at, okay, in the original thing, the decimal point is here. And we went 1, 2, 3, 4, 5, 6, 7. 7 decimal points backwards. So what we're going to do is multiply by 10 to the 7th power. And that's going to be our answer right there. And you can also test this. So 10 to the 7th power is 1 with 7 zeros at the end of it. So 1, 2, 3, 4, 5, 6, and 7. And basically, we know that these zeros, if we're multiplying, basically indicate how many spaces we're going to go. So if we go 7 spaces, we're going to get 3. The decimal is going to move 1. And then it's going to be 6 zeros. Since we have 6 more zeros left to go, it's just going to be zeros now, where the decimal points would be. Right, so it moved 1, 2, 3, 4, 5, 6, 7. And as you can see, this is 35 million, which is the exact same number we started with. And this is how you're going to be able to use scientific notation to express very large or very small numbers. So now we'll go into a small number. For instance, a very long decimal, something like 0.0007, something simple to start out with. So basically our first significant number, which is going to be 7. So we're going to have 7 multiplied by 10. And the way to remember this is that when you're taking a very large number, it's usually going to be a positive number here for n. And if it's a very small number like this, which the decimal starts here and it's zeros after the decimal, which is a very small number, it's going to be a negative for the n. So what's going to happen is decimal moving 1, 2, 3, 4 over to the right for us to get this 7 here. So in order to counteract that motion of moving the decimal 4 to the right, we're going to have to say this is 10 to the negative 4 here. And once again, if we look at what this means, this is going to check out since 7 times 10 to the negative 4 is the same as 1 divided by 10 to the 4th. And that number is going to be 10 to the 4th. We're just going to put a 10 with 4 zeros at the end, which is going to be the same as 7 divided by 10,000. And what this number here is really 7 divided by 10,000, and we can do this division out basically. And if you want to see further, if we do this division, going to get 0 point, and we're going to have to put 4 zeros until we can actually get somewhere. And here at the end, we can finally put a 7. And there's your answer. And there's the same thing as the start. Now, what this number here is if we're using our place values, we can say that this was tenths, this is hundredths, this is thousandths, and this is 10,000ths. So this was 7 10,000ths, and that's exactly the number we have here in fraction form. And we can also do this kind of thing with longer numbers for the very small numbers, which is something that we need to go over since the smaller numbers are the bigger problem. Because no matter how big a number is, when you have something like this, let's say 2, 3, 4, right? 234,000, all we do is go to the first number, which is 2, right? Put the decimal here, and we're going to have to 2.34, right? If there are actual numbers after where you put the decimal point, you have to include them if they're not zeros. If they're zeros, then they become part of the multiplied by 10 to the n part. But if you have more numbers here after where you're going to be putting the decimal point, you have to include that as well. But this is going to be 2.34 multiplied by 10 to the power of, and we can see that the decimals here is 1, 2, 3, 4, 5. 10 to the 5. And that's going to be our answer. So if we're using an extremely small value once again, and it's 0.00415, for instance. Well, first we're going to look for our first actual value that's not 0, which is 4. So we start from there, put the decimal point immediately after, and then we have to include the 1 and the 5 since those are numbers that aren't 0 as well. So 4.15. And we're multiplying this by 10 to the power of some number. Now, let's basically see how this works. The decimal point went to the right by 1, 2, 3. So it's going to be 10 to the negative 3, since this is going to be a very small number. So you can sort of figure out that when it's a very small number, it's going to be negative for this value of n, which is the exponent. And one more important thing to note is that, and this goes for the large numbers and the small ones, if you have some number, let's say 2.001500, right? With this number, you have to always include any number that's not 0. So when you calculate this decimal, this is the most important part of these kinds of calculations. When you say, okay, the decimal has to come after the 2 because that's the first real number, that's not a 0. You have to put all of these zeros in here in order to include the 1, 5 at the end. So even though those are zeros, because there's a 1 and a 5 here, we have to include all of that. So you include everything until you get to a point where there's only zeros at the end. And then you can safely multiply by 10 to the power of whatever you're multiplying by. And in this case, that would be 1, 2, 3, 4, 5, 6, 10 to the 6th power. And as you can see, if you basically do the decimal, unravel it, and then you're just going to have the extra zeros, which are these extra zeros here. And the same goes for your very small numbers. This is very important to remember. If you have 0.04031, you have to first find the first number, which is the 4, put your decimal point, and you have to include all other numbers afterwards. 4.031, multiply that by 10 to the negative, since our decimal is here, it got moved 2 spaces, so 10 to the negative 2. And if you do that calculation, you can see that this is basically going to be 0.04031, which is our original number. So these can be quite simple, but the main thing to remember is that once you have any numerical values that aren't zero, they have to be included in this A. A is basically whatever you have before the multiply by 10 to the end part. So this 4.031, make sure you include all of these numbers and once you include all of those numbers and identify how many spaces the decimal is moved, if you're moving the decimal to the right, in the original equation, so for instance, in here we moved it 2 spaces to the right, then you're going to have a negative 2 because really this 4.031 is a higher number than 0.04. So we have to multiply that by 10 to the negative 2 to get it back to that. And the same thing for the very large numbers. If you have a very large number like 5,451,000, write your A, you have to include everything else. And since you're moving the decimal from here, 1, 2, 3, 4, 5, 6, you're moving it 6 to the left, that means you're going to have a positive here, 10 to the 6, because this 5.41 is obviously much smaller than the 5 million. So you have to multiply that by 10 to the positive 6 so that you can increase by that amount. And that will do it for this topic, scientific notation. I hope that you enjoyed the video. I hope this was helpful, and I hope you'd see you in the next one.